So as I mentioned in the previous video, is that finite automata means that there might be some searching around, that you may be given more than one option when it comes to some type of input that you're receiving. In a deterministic, it's you in this example, our alphabet's just going to be zeros and ones. So if you look at any state that you have here, you're only going to have one option of a 1 coming out and one option of a 0 coming out, and that's it. So that's the difference between a deterministic and a regular finite automata. So in this aspect, the DFS can have multiple accept states. And the accept state is what you can tell is going to be a double ringed form of a state. You can also tell what the start is going to be because I'm giving you an arrow, but even if I didn't give you the start state, you know it's going to be S of 0 because it's 0, and that's our first number as we progress from there. So the important part is again, remember, we are using this as another tool to understand input that we're going to be receiving and then what to do with that input. Put it into a parse tree, have it determine syntax and if it's correct or something of that nature. These are all things that we're going to visually see, but we would use a regular expression to actually code it and get things done. But sometimes we need to visually see what's happening first. In this particular finite automata, or really DFA, it's going to accept only binary numbers that are multiples of 3 base 10. So 3, 6, 9, 12, but what they look like in binary. So I want you to answer the questions that I have on here, and then we'll go over some solutions here. But remember, what is my primary goal for this whole thing is actually this sentence right there, and that's why it says super important on the other end there. So fill out the problems. Again, remember what this particular DFA is meant for. Go from there. We'll go over some answers here in a second. So I'm going to break this up into a little bit of this with a green screen, and then we'll go back to the light board here in a minute. But let me answer 1 and 2. What does an accept state mean for the application? The application is, again, the important part. Only accepts binary numbers that are multiples of 3 base 10. So if we end up at somehow we end up at the accept state, that means we've done a combination of zeros and ones that got us back to this part. So if you were to draw out any set of numbers, again, shifting from zeros to 1, and end up here, I bet if you converted that binary number to a decimal, it'd end up being some multiple of 3. So that's the answer for number 1. And then what state is both the start state and the accept state? I think I kind of went even over that before we went into everything. And that's really the first one right there that we have with C0. By the way, you are going to see other ones that have other accept states. So just a heads up, it's not always just one. There's also one that I'm going to talk about here in a little bit later on. This really does not apply for this application, but there might be another state. We call it a sync node that basically, if you've reached it, there's no way of coming back and that the input is an error. So I'll go over that here in a little bit, but just trying to get your heads wrapped around what this is going to be. And next you'll see me complete the exercises that we have down here and which state that you'll end up on here in a moment. So let's take a look at our problems here. So first of all, there's going to be 2 parts to this. First, we're going to see if it's going to be even accepted. And then Y is really the next part. So let's take a look here. We're going to go 0, 0, 0, 1. And notice I'm going to do it from left to right. And we'll use a chart here. At 0, we go back to state 0. Another 0, then another 0. It's a third 0 that I've just done. And then I do a 1. Okay. Was it accepted? I'm going to put a no. Our next one is 1, 0, 1. So we'll have a 1 here. Start from always a start state. Go to 1. End up at state 1. Then we do a 0. We'll end up at state 2. Then we'll do another 1 and goes right back to states 2. Is that an accept state? The answer is no. Next one. There's 2 1s. 1, 1. Notice it goes to state 1 first, then back to state 0. And then the rest of them are zeros. So it does go back. And this one, before it changes, actually, go figure, this one is a yes. And again, we'll go over why here in a minute. Last one, or next to the last one here, we'll have a 1, goes to state 1. A 0 goes to state 2. Another 0 goes to state 1. Another 0 goes back to state 2. Then a 1. And then 0 back to state 1. Is that an accept state? The answer is most definitely a no. And then the last one. I don't know why I made this one that long. Go from start state 0. Go to 1. Or use 1 to get to state 1. Now we do a 0. Goes to state 2. Another 0 goes back to state 1. A 1 takes us back to the state 0. A 0. 0. Then a 1 goes to state 1. A 0 goes to state 2. And then a 1 stays at state 2. So this is another no. So out of all these, only one of these is a yes. Why?